Information criteria for nonlinear time series. Outline. Introduction. Purpose of the study. Nonlinear time series model star. Information criteria. Numerical examples. Conclusions. References. Introduction. Fundamental information. Time series emerged as a result of the analysis of experimental data observed at different points in time in statistical modeling and inferences, and the necessity of examining new and unprecedented problems. Systematic approaches used to find answers to mathematical and statistical questions posed by this time correlation are called time series analysis. The main purpose of time series is to determine the values obtained by observance in probability rules. This type of series is called stochastic time series. In order to make time series analysis trends, conjecture, fluctuating seasonal effects, and random variables should be controlled, which cause bias in parameter estimation and which do not take into account the asymptotics such as stagnation. Introduction. Modeling time series. To determine the modeling in the time series, the following steps are usually followed. Time series graph is drawn and general idea is obtained by examining the graph about the data, trends, seasonality, outlier, changing or unchanging variance, and nonlinear and non-stationary conditions are examined. Autocorrelation and particle autocorrelation values of the original time series are calculated, plotted, and examined to provide information about correlation and autocorrelation. The first two steps are examining I and operations correlation are taken and the new series is plotted. Again, autocorrelation and particle autocorrelation values for the new series are calculated and plotted. While autocorrelation guides the determinant of the AR model, particle autocorrelation plays a role in the determination of the MI model. When interpreted together, ARMA model is formed. Purpose of the study. Once the degree of the model is determined for the time series, the best parameter estimated for the model are made. For the parameter estimation, moments method, maximum likelihood method, and least squared method can be used. There may be more than one stable model that can often be used in the time series analysis or statistic data analysis. There are some criteria for determining the model suitable for the data in the time series. AKK information criterion, Schwarz information criterion, weighted information criterion, Mallow's CP criterion, generalized cross validation. The purpose of the study is deciding the optimal nonlinear time series model in terms of corresponding data set with using segmentation criteria. Nonlinear time series models. In order to obtain general information from financial datasets, it's become necessary to apply methods that allow temporary breaks, asymmetric movements seen in the transition of stocks exchanges from downturns to upturns can be seen. Even if such phenomena, which cause shifting from linearity do not occur, it is recommended that time series be analyzed with nonlinear models for economic theory. The most basic approach in the analysis of time series with nonlinear models is the definition of different states and then the possibility that the dynamic behavior of economic variables depends on the states or states. Inspected kind of nonlinear time series are given for this study: threshold autoregressive model, smooth mutation autoregressive model, self-exiting threshold autoregressive model. Nonlinear time series model STAR. It was incorporated into the financial literature by Tong and Kimin, and later expanded in Tong's work. Time models set a certain threshold and enable different regimes to be applied to financial series. Thus, while each regime remains linear within itself, the entire series may exhibit nonlinear properties. TAR-11 model with two regimes is shown below with parameters AR here, and the autoregressive confidences of the first regime and autoregressive confidences of the second regime. See the threshold value and are the error terms. In both of the above regimes, it is estimated that the error terms and distributed independently and homogeneously and have white noise characteristic. Nonlinear time series model SETAR. This model was first developed by Tong and Lim and ended to the literature. A special case of the TAR model, the SETAR model, is shown below with an example of a SETAR model with two regimes. Size error terms come from an independent distributed population, ordinarily squares, are used in parameter estimations. However, model parameters are estimated by using conditional CLC method in SETAR models according to nonlinear station. Nonlinear time series model CLC as a function of the threshold parameter. It is estimated as the values that minimize the sum of the conditional least squares. For given threshold, some simple algebraic operations can show that autoregressive coefficients can be estimated as below. Nonlinear time series models STAR. A generally STAR model associated with a smooth translation function is given by two autoregressive regimes such as: the smoothness of the translation function means that the function changes continuously from 0 to 1 and therefore provides a smooth translation between the two regimes. Alternatively, a STAR model can be interpreted as the continuum of regimes passing through the process. Nonlinear time series models LS-STAR and S-STAR models. Given in the STAR model, logistic function is used as the translation function. LS-STAR model is obtained. In other words, as a translation function. Similarly, if exponential functions is used as transition functions, STAR model turns into A-star model. In this context, exponential function is nonlinear time series estimation of the star models. Once the star-type nonlinear series is determined in the time series, a star model can be set up. This usually requires selecting the shape of the translation function and the translation variable. Generally, the choice between A star and A star can be made using different information criteria or by considering particular translation behavior under investigation. The nonlinear least squares estimator of the parameters of the least star model is defined as below. Nonlinear time series estimation of the star models. When the star-type nonlinear series is determined in the time series, a star model can be set up. This usually requires selecting the shape of the translation function and the translation variable. Generally, the choices between least star and A star can be made using different information criteria or by considering particular translation behavior under investigations. The nonlinear least square estimation of the parameters of the least star models is defined as below. A star estimation of the model is the same as the prediction process of the least star model. Only the exponential function is used as the translation function. A star model is also considered in asymmetric structures. Simulation experiments. Simulation experiment data generation. Data generation from linear and nonlinear models and sample of varying sizes to determine the factors affecting the performance of the information criteria. The volume of the sample, model's parameters, degree of superiority, and number of regimes were changed during data generation. 4 different R models are considered to generate data from the arch-grade AR models. For each different sample volume, the process of generation data through simulation in this was impaired by Capetanius. Simulation experiments data generation. The error times in each of the above models were derived from the standard normal distribution with a mean of 0 and a variance of 1. 3 different samples were generated from each model. In the simulation study, each of the samples with 3 different sizes was repeated 1,000 times. Least star models are generated with 2 regimes as table 2. Generation of A star and star models are given table 3-4. In addition, mean square error is used as the performance measure for estimating volume obtained from the models. In this study, 16 different time series models were projected. Of these 16 different models, 4 were considered linear and the remaining 20 were considered as nonlinear time series models. To determine the correct model selection ratios, AKK, Schwarz, weight, and CP information criteria, the R program writing by use was used in the statistic packet program. Simulation results are based on 1,000 repetition. The results showing the mean values of the mean error scores are summarized in the following charts and graphs. Simulation experiments results. As shown in table 5, which shows AR models, generalized cross-validation is the criterion for selecting the most AR one model in 1,000 repetitive simulation class with 15 sample selection. In other words, generalized cross-valuations criterion is the most powerful criterion. On the other hand, Schwarz information criterion showed that character was the worst criterion by making the less selection. At the same time, the AI2 models was chosen as the best Mallows CP criterion and the worst AKK information criterion. AR3 has chosen the best generalized cross-valuation criterion and the worst Schwarz information criterion. The AR4 is the best Mallows CP criterion and the worst AKK information criterion. Simulation experimental results. When AR models are compared, is it seen that the model with the best or smallest mean square error value is AR4. In this case, he can say that the AR2 model selects by CP criteria is more successful than the others. This is also supported by figure 1, which includes the box graphs of the mean square error values. In other words, when the mean square errors are examined, it is seen that the AR2 model has the smallest median mean square error value. As shown, generalized cross-validation is the most important criterion for selecting the A*11 model in 1000 repetitive simulation cycles. In other words, generalized cross-validation criterion is the most powerful criterion. At the same time, we can say that A*22 is the worst AKK information criterion when choosing the best CP criterion, and A*34 is the worst AKK information criterion when choosing the best generalized cross-validation criterion. When the A* models are compared, it is seen that the model with the best or smallest mean square error value is A*11. In this case, the A*11 model selected by the generalized cross-validation criterion may be more successful than the others. In other words, when the mean square error axes are examined, it is seen that A*11 model has the smallest median mean square error value. In other words, when the mean square error axes are examined, it is seen that the A*22 model has the smallest mean square error value. Satire models, as shown in table 710, 100 simple selection CP is the information criterion that selects the most satire 1 model in 1000 repetitive simulation cycles. In other words, the most powerful CP criterion is the power of selection. The AKK information criterion was the worst criterion by making no choice at all. At the same time, Satire 1.3 is the worst AKK information criterion by choosing the best generalized cross-validation criterion, and Satire 2.1 is the worst Schwarz information criterion by choosing the best CP criterion. Satire 2.2 model is the best generalized cross-validation criterion, while the AKK information criterion is the worst criterion by making no choices at all. Setter models are compared and it is seen that the model with the best or the smallest mean square error value is setter 2 In this case, the setter 2 model selected by generalized cross-valuation criteria may say that it is more successful than the others. This is also supported by figure 3, which includes the box graphs of the mean square error values given in the table. In other words, when the mean square error axes are examined, it is seen that the setter 2 model has the smallest median mean square error value. When the simulation results are taken into consideration and 50, 100 and 200 simple data, 1000 repetitive simulation, the AR1 model, GCP creating, AR2 model, CP creating criterion, AR3 model, generalized cross-validating, and AR4 model, it can be said that the CP criteria. Theoretical information on selection methods shows that the generalized cross-validated criterion, which aims to reduce the complexity of the model with the backward screening process to eliminate excessive fit, also has the best selection by eliminated the basic function with the least contributed to the model. When the model performance indicators are analyzed when AR models are compared among each other in terms of mean square error values for n 15 simple data, it is seen that the model with the best or smallest mean square error value is AR4. For n 100 simple data, AR4 is said to have the smallest mean square error. When the star models are analyzed according to the simulation results, we can say that the correct model are selected by the best generalized cross-valuation criterion in 1500, 200 simple data and 1000 replications. In this context, A star 11, A star 34, Le star 22 and Le star 34 models are selected by generalized cross-valuation criterion, while A star 22 and Le star 11 models are selected by CP criterion. At the same time, we can say our determination for AR models in star models, and we can say that the general cross-valuation criterion, which aims to reduce the complexity in the model with the back-saving process in order to eliminate an excessive fit, has the best selection by eliminating the basic function which has the least contributed to the model. When the model performance are examined, when the setter model for 15 sample data are compared, it is seen that the model with the smallest mean square error value is A star 11 model selected by generalized cross-valuation criterion. When the Le star model are compared, it is seen that the model with the best mean square error value is the Le star 11 model selected by generalized cross-validation criteria. When the A-star models are complete and complete among each other for hundreds simple data, it is seen that the model having the best mean square error value is the A*11 model selected by CP criteria. When less-star models are compared, the less-11 model selected by the CP criteria is more successful than the others. When A-star models for 200 simple data are compared, it is seen that the model with the lowest mean square error value is A*11 model selected by generalized cross-validation criteria. Conclusions. When the simulation results of SETAR models are examined, it is seen that the above maintained models are mostly used is estimated with 50 units simple data products by SETAR11, SETAR13, SETAR22 models information criterion. In addition, it is understood that SETAR21 and SETAR43 are the most preferred CP criteria, while other criteria are less selected. In the simulation study, when the results of the simple data obtained from these models are examined, the CP criterion of SETAR11 and SETAR21 models are the most common CP criterion. SETAR13, SETAR22, SETAR32 and SETAR43 models are the most preferred generalized cross-validation criteria. When we look at the result of units of simple SETAR11, SETAR13, SETAR21, SETAR22 models are mostly generalized cross-validation criteria. SETAR32 and SETAR43 models are mostly selected by CP criteria. Thank you for listening.